Welcome to Spaceverse, your portal to cosmic adventures. In today's episode, strange events are unfolding aboard the International Space Station. There's major news for Starship in 2025, intriguing moves from China, and Rocket Lab doubling its efforts with Electron. But first, what's that smell? A foul odor has emerged on the ISS, and this time it's not the zero-G toilet. The source seems to be a newly docked Progress spacecraft on the Russian side of the station. The story begins with Russia's Progress Ms-29, which docked with the POA module on November 23rd after launching from the Baikonur Cosmodrome aboard a Soyuz rocket. The uncrewed supply ship delivered 2,500 kilograms of cargo, including food, water, and propellant. However, when cosmonauts opened the hatch, they were hit by a strong, unidentified smell and droplets of an unknown fluid floating inside. NASA later confirmed this incident via social media. In response, the Russian crew quickly resealed the airlock to the Progress spacecraft and even closed the POA module hatch to isolate the issue. For now, that section of the ISS remains quarantined as the situation is investigated. So what's up with the smell? Sure, it might sound like a funny story at first, but it could be more serious than NASA is letting on. According to Anit Zak of Russian Space, a respected independent site, the odor was described as toxic, prompting Russian cosmonauts to immediately seal off the Progress spacecraft. Meanwhile, over on the US side of the ISS, NASA astronaut Don Pettit said the smell reminded him of spray paint. Both US and Russian crews have activated extra air scrubbers, and the station's air quality is reportedly back to normal. But here's the big question: now what? The supplies, food, water, and equipment are still locked in the Progress module alongside the mysterious odor. It's not like they can hit next-day delivery on a fresh shipment, so this could pose a real problem. And while everyone's working on that issue, rumors are swirling about another challenge: the health of astronaut Sunita Williams, who's spending more time in space than planned after the troubled Boeing Starliner mission. To clear things up, let's squash the drama. No, Sunita isn't wasting away in space, as some tabloids claim. Sure, she's 59, which is older than the average astronaut, but she's handling life in microgravity just fine. For context, her mission partner Butch Wilmore is 61, and NASA's Don Pettit is up there at 69, showing off his sharp sense of smell. Age clearly isn't holding anyone back. Now let's talk about life on the ISS, because it's not exactly a vacation. Astronauts work out for over 2 hours daily, doing cardio and weightlifting to maintain muscle and bone health. That level of exercise means they need to eat a lot, 2,500 to 4,000 calories per day, depending on their body type. They also eat less salt because the body retains sodium differently in space. Combine this with the effects of microgravity, and it's no surprise that their bodies undergo changes in fat, muscle, and water distribution. So, while the mystery smell and food quarantine are concerns, they're far from an existential crisis. The ISS crew is well-trained and resourceful, and they'll tackle these challenges head-on just like they always do. Sunita says she weighs the same now as she did when Starliner launched in June. While she might have lost a little puffiness in her face, she's reportedly gaining muscle in her lower body thanks to resistance training, specifically squats and deadlifts, which she admits aren't part of her usual workout routine on Earth. But this brings up a fun question. How do astronauts weigh themselves without gravity? Enter the Space Linear Acceleration Mass Measurement Device. This ingenious contraption acts like a sideways pogo stick that gently pushes against the astronaut's belly, sending them backward. Using an optical instrument to measure their acceleration, it applies the classic formula force equal mass times acceleration. Since the force of the spring is known and we measure acceleration, solving for mass is just a bit of algebra. Don't worry if you're rusty, we've got your back. Oh, and about that headline claiming Sunita and Butch are drinking soup made from their own pee, that's not a survival hack, it's just astronaut life. The water on the ISS is highly recycled, so yes, it includes processed urine, sweat, and even humidity. Don't worry, it's purer than most tap water on Earth. Big news for Starship. The FAA has released an updated environmental assessment for Starbase, Texas, that could significantly increase its annual launch and landing capacity. The proposal covers up to 25 Starship launches a year, along with 25 landings each for the Super Heavy booster and Starship upper stage. While this is a promising step forward, it's not a done deal yet. The FAA has opened a public comment period through January 17th, with 4 in-person meetings scheduled in Texas in early January and 1 virtual meeting on January 13th. Conveniently, this timeline aligns with rumors of Starship Flight 7 potentially launching on January 11. Elon Musk has hinted that if they successfully nail another controlled water landing in the Indian Ocean, Flight 8 could attempt the first orbital return to the launch site. Fingers crossed. Meanwhile, over in China, the nation's space program is quietly making fascinating progress. Their Christian 19 retrievable satellite recently returned to Earth after a 2-week mission, landing via parachute on October 10th. The mission featured some groundbreaking tests, including a small inflatable module, China's take on a concept similar to Bigelow's beam module on the ISS. Though the Chinese version was smaller and short-lived, it signals a move toward inflatable habitats for future space outposts, potentially on the Moon or as expansions to their Tiangong space station. Adding to the intrigue, China also experimented with breeding plants in space. By exposing crops to microgravity and radiation, they hope to encourage beneficial mutations that could boost crop resilience and productivity. With limited fertile land relative to their population, this research could prove game-changing. Plus, it's fun to imagine the possibility of space veggies playing a role in their lunar or orbital colonies. As always, China keeps their cards close, so we'll have to wait and see how this evolves. And finally, Rocket Lab is proving it's no small player in the space race. In an impressive feat, they launched 2 Electron rockets within just 24 hours, continuing to grow their share of the space launch industry. Rocket Lab recently achieved a significant milestone with back-to-back launches of its Electron rocket within a mere 24 hours, showcasing its growing capabilities in the competitive space industry. The first of these launches occurred at 1 a.m. Eastern Time from Launch Complex 2 on Wallops Island, Virginia. This mission featured a specialized suborbital version of the Electron rocket, known as the Hypersonic Accelerator Suborbital Test Electron, which is designed for hypersonic testing applications. It's a niche but critical area of aerospace research, highlighting Rocket Lab's ability to cater to a diverse range of missions. Not long after, Rocket Lab executed its second launch from Launch Complex 1B in New Zealand at 10:55 p.m. Eastern Time on November 24th. This mission was a fully orbital flight, successfully deploying the third batch of 5 satellites for the French company Kinais. These satellites are part of Kinai's ambitious plan to establish a constellation dedicated to Internet of Things connectivity services aimed at enabling global communication for IoT devices. This launch follows 2 earlier missions in June and September, marking the third out of a 5-launch contract that was initially announced in 2021. The remaining 2 missions are scheduled to be completed by the first quarter of 2025, underscoring Rocket Lab's commitment to fulfilling long-term agreements with precision. The significance of these launches goes beyond the payloads themselves. They set a new company record for fastest turnaround time between consecutive launches, reducing the interval to less than a day, a major leap from Rocket Lab's previous record of about 1 week. Such rapid reusability and operational efficiency are critical for competing in the modern space industry, where demand for frequent and reliable launches is ever growing. In terms of overall performance this year, Rocket Lab has successfully conducted 14 Electron launches, a strong achievement for a relatively new and modestly sized company. However, this figure falls short of their original projection of 22 flights for the year. Rocket Lab CEO Peter Beck has since revised the forecast, stating that the company is likely to conclude 2024 with somewhere between 15 and 18 Electron launches. While slightly below initial expectations, this adjusted goal still represents a substantial step forward, particularly considering the complexities of maintaining a rapid launch cadence while ensuring mission success. These back-to-back launches not only demonstrate Rocket Lab's growing capabilities, but also solidify its reputation as a dependable partner for both commercial and government customers. As the company continues to refine its operations and expand its launch infrastructure, it's positioning itself as a formidable player in the ever-competitive landscape of small satellite launches. The future for Rocket Lab looks bright, with its ambitious plans setting the stage for even greater achievements in the years to come. And that's it. Thanks for watching Spaceverse. From ISS mysteries to Rocket Lab's record launches and Starship updates, we've got the cosmos covered. Like, subscribe, and hit the bell for more. See you next time.